reflections of graphs. The graph of f of x will reflect across the x-axis by simply changing the sign of the entire function. If you change the sign of only the x, the graph will be reflected around the y-axis. So let's look at an example of each. Let's look at the graph of y equals 2x plus 4 and y equals negative 2x plus 4. When we look at these equations first, notice that the only thing different about the equation is the sign here, which basically is just the sign in front of the x. So what we have here is our x in this equation has been replaced with a negative x, which gives us the negative 2x plus 4. So let's look at our graphs. Let me take my highlighter and show you that the first graph, y equals 2x plus 4, is my yellow line. Okay. Now, if I want to reflect that yellow line across the y-axis, think about folding this graph along the y-axis, folding it vertically. Well then, where would this yellow line match up? This yellow line would match up along this line. So this line is the line of y equals negative 2x plus 4. So you see these are reflections across the y-axis. Let me get my ink color back here. Let's look at the table of values for each of these. Here, notice that I've used x values of negative 2, negative 1, 0, 1, and 2. My y values are 0, 2, 4, 6, and 8. That's my original function. That's my yellow function. If I want the reflection around the y-axis, what that's going to do is it's going to basically reverse the sign of the x-coordinates. So the negative 2 that was paired with a 0 to begin with is now going to be paired up with the same number as the positive 2 was. Here we have the point positive 2, 8. But in the reflection, we have the point negative 2, 8. Same thing is true for negative 1. In the original graph, we had the point 1, 6. But in the reflection, I get the negative 1 paired up with the 6. The 0, of course, 0 doesn't have a sign, so it doesn't change. But then the negative 1, 2, in the reflection, reflects to the point 1, 2. And the point, oops, this is supposed to be a 0 here. Negative 2, 0 reflects to the point 2, 0. Now let's look at an example that reflects around the x-axis. In order to get this reflection, I have an original function, y equals 2x plus 3, and then I change the sign of the entire function by simply multiplying it by a negative. I also could have written that as y equals negative 2x minus 3. So let's look at the graphs. Again, let me change to my highlighter so we can tell which graph is which. Here, y equals 2x plus 3 is going to be this graph. It's the line that has the positive slope. So, the graph of y equals negative 2x plus 3 is the one with the negative slope. Now if we look at this graph is the mirror image of the green graph if we fold it along the x-axis, not the y-axis, but think about folding it along the x-axis right here. So basically fold the top of the page down to the bottom of the page so that this part of the graph would be matching up with this part of the graph, and this part of the graph would be matching up with this part of the graph. So now, let me get my regular pen back. And look at these tables. Here what changes isn't the sign of the x, but rather the sign of the y coordinate. Notice that in each ordered pair, the only thing that's different is the sign of the y coordinate.